Hey guys, Mr. Vickery here. Today we're going to talk about the heat of solution and how it applies to the lab you're about to complete. Heat of solution think of it this way. I kind of tried to simplify it a little bit for you. The energy change associated with the dissolving process. So when you dissolve something in water, there's usually an energy change associated with that, and more specifically, what you would see or feel or be able to measure is a temperature change. So when you dissolve a salt in water, sometimes the water gets warm, sometimes the water gets cold, and that's what heat of solution is. So in order to understand it, we're going to dig a little deeper into what's actually happening. So we've all dissolved salt in water, but have we ever really tried to understand what's actually happening? So when I put the salt in the water, I want you to think about it like this. What happens when a salt dissolves? It turns out there's more than you think. It's not simply mixing salt and water. Does the solution get warm? Does the solution get cold? And the most important question is, why does the solution get hot or cold? To really understand the energy change that happens when something dissolves, we have to zoom in and take a look at an individual salt crystal. And this happens to be sodium chloride, NaCl, table salt. It consists of positive and negative ions. The green are negative ions, or the chloride. They have actually gained an electron if you know your ions. Sodium has lost an electron, now it's positive. So we have this entire network, and really it's what they call it is a crystalline structure of positive and negative ions that forms this lattice. And if you know anything about opposites and how they attract each other, we have the negative charged chlorides and the positively charged sodiums, and they are attracted to each other quite strongly, in fact, in all directions. And that attraction is called an ionic bond. So part of understanding the dissolving process is that we have got to break those ionic bonds, or this salt cannot dissolve. So remember that when we continue, we have to break those bonds. Second thing to understand in the whole process is if we were to blow up water and zoom in, water is a bunch of H2O molecules, and what you might not have known about water is that it is a polar molecule, meaning it shares its electrons unevenly. What happens as a result of that is on the oxygen end we have a negative charge, and on the hydrogen ends we have slightly positive charges. So it acts kind of like a little magnet. And in fact, if we zoom in on these water molecules, we have the negatively charged oxygen, positively charged hydrogens. They are actually attracted to each other. And you can see the line here kind of indicates that there's a bond there. In fact, that bond is called a hydrogen bond. And in order for water to now act on this sodium chloride, these hydrogen bonds have to break. So here's what actually happens in the dissolving process. Water molecules will start to interact with the outermost ions in this crystal. Remember, this sodium is positively charged, and the water is negatively charged in that end, positively charged here and here. So it'll actually form these little bonds, and more waters will jump in there and start to pull at those ions, so to speak. Eventually, they will pull themselves free, and what you'll have is a sodium ion surrounded by water molecules. And that is how, and it'll keep doing, and this happens very quickly, it'll pull these salt crystals apart, and each ion will then be surrounded by a set of water molecules. And if you think about it, I'm going to erase some of these. If this was the chloride ion, the negative one, the water orients itself in a slightly different manner around the chlorides, meaning the positively charged hydrogens are now forming little bonds with the chlorides. So this is all happening very quickly, and we get these little bonds that form between the chloride atoms and water. So think about these breaking of bonds and forming of bonds, and think about the energy that's associated with those. So there's really three things that are happening. We are breaking ionic bonds, so we have to break those bonds. We are breaking intermolecular forces between, or the hydrogen bonds between waters, but we are forming new bonds. So there's a couple of things to remember when thinking about breaking bonds and making bonds. This is a very important phrase. It helps you keep it all straight. Breaking is taking. In other words, breaking bonds takes energy. So if that's true, forming bonds must release energy. So remember that when we advance to the next slide. So breaking is taking. We've broken two bonds, which takes energy. But that third bond, the one that we're forming, and this is all happening simultaneously, releases energy. And here's the whole process in a nutshell. If I have a beaker of water at a certain temperature, let's just say 22 degrees Celsius, and the taking of energy, or breaking bonds, takes energy, and it's actually taking it from the water, which would actually lower the temperature. So the energy it takes to break those bonds lowers the temperature, but the energy released by forming of bonds increases the temperature. So we've got these three things happening simultaneously that are fighting back and forth in a sense in trying to raise or lower the temperature of the water. Whichever one wins is the one that's successful. So let's say that the breaking takes more energy than this releases. Then the temperature of the water is going to go down, maybe to 19 degrees. If the energy released when these are formed is greater than the cost of what it took to break those bonds, then your temperature is going to go up, maybe to 28 degrees Celsius. So let's sum it all up on the last slide. The first two processes, breaking those bonds, takes energy. The forming of bonds, releases energy. If the sum of all that, if it takes more energy than is released by the forming of bonds, then we call that a endothermic process. And the temperature of the water goes down. If the amount of energy released is greater than the cost, then we have an exothermic process, and the temperature of the water goes up. This is a very condensed version of the dissolving process and how it applies to exothermic and endothermic reactions. But that's the basics, and I think that'll help you get through the lab.